Hi, welcome to Unit 7, Day 3, Proving Parallelograms. So today we're going to be looking at when we're given a quadrilateral, something that has four sides, how we can show that it is indeed a parallelogram. You can't, unfortunately, just look at a shape and say, oh, that looks like a parallelogram, and call it a parallelogram. We have to have some more information. There are 5 different ways to show that a parallelogram is a parallelogram, or that a quadrilateral is a parallelogram. So let's look at those. The first one says if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. There's 2 ways you can prove that opposite sides are parallel. The first one, well really 3. The first one is it can be marked in the picture for you. So you could have the little matching triangles that say the left side is parallel to the right side, and then the top side is parallel to the bottom side. You could also have directions when you read the prompt for the directions that tell you the sides are parallel. And then you could also be able to prove by the angles that you have parallel sides. So you could prove that you have parallel sides. If it's graphed, you could look at the slopes, because remember, parallel sides or parallel slopes are equal. So if these are graphed, I know these will have equal slopes here and then here. Okay? All right, number 2, if both pairs of opposite sides are congruent. And again, there's several ways you could know that. It could be marked in your picture with tick marks. It could be given to you when you read the prompt that goes with the question. Or on a graph, you could use the distance formula to find this length and to find this length to know that those are the same. And then you could use the distance formula here and here to know that these 2 sides are the same. Okay, so on a graph you can use your distance formula or convert them to little right triangles in Pythagorean theorem, or it might be marked for you in the picture, or it might be given to you in the directions. Okay, so again, the first one, both pairs of opposite sides are parallel, both pairs of opposite sides are congruent. The third way is both pairs of opposite angles are congruent. If that's true, then your quadrilateral is a parallelogram. So if my lower left is the same as my upper right, and my upper left is the same as my lower right, then I know I have a parallelogram. Even though I don't know anything about the sides, if I can show that this is true, then I have a parallelogram. The easiest way is going to be it's marked in the picture for you like this, or it's going to be given to you in the prompt. Okay? All right, and then number 4, diagonals bisect each other. So remember what that's going to look like is you'll have your diagonals drawn in. And remember, that doesn't mean we end up with 4 equal parts. That means this downward sloping diagonal is cut into 2 equal parts, and this upward positive sloping diagonal is cut into 2 possibly, most likely, different equal parts. Okay, because generally you'll have a shorter diagonal and you'll usually have a longer diagonal. Occasionally they'll be equal, and we'll look in the future what that tells us about the particular parallelogram, where they are equal to each other. But generally they're going to be 2 different lengths, so you'll end up with 2 sets of equal segments. Okay? And then the last one that we have, if one pair of opposite sides is both congruent and parallel. So when I looked up here, it had to be both pairs and both pairs, and this one had to be both diagonals, because again, if only one diagonal is bisected, that's going to give us a whole nother shape that we're going to talk about later next week. And then the last one here, if one pair, so notice this time we're a little bit different. We're still we're still pairs, but we're only one pair of opposites. Okay, so we had both pairs of opposites, both pairs of opposites, both pairs of opposites. We had both diagonals. Now we have one pair of opposite sides, and it's going to do 2 things. So they're still both. it's that one pair of opposite sides is going to do two things. They're going to be congruent, which means you would have tick marks, or if it's on a graph, you could use the distance formula to figure out how long they were. And they're going to be parallel, which means they would need to have the same slope on a graph, or it needs to be marked for you in the picture or given to you in the directions. Okay? All right, so when I look at these examples, can we prove the following quadrilaterals are parallelograms? Okay, so when I look at number 1, I can see that I do have parallel sides. I have one pair of parallel sides. And then I have that same set are both 12. So they are also congruent. So I have one pair of opposite sides that is parallel and congruent. So using my fifth theorem, I can say yes. And I'm just going to put a number 5 so we can remember it's the fifth one in our list. It might be different in different textbooks, but it's the fifth one in these notes that I can refer back to as to why number 1 is indeed a parallelogram. Okay, number 2, on number 2, I see all my sides are the same, and it's real tempting to call this a square, but remember a square back from elementary school, middle school, you also need to make sure you have those 90-degree angles. This could be tilted just a little bit, making it more like a diamond, which we call a rhombus, we'll talk about later in this unit. So don't automatically look at this and assume it's a square, even though it kind of looks like one. I can see I have tick marks, so I have congruent sides. The ones that talk about congruent sides are number 5. I have one pair of opposite sides, congruent and parallel. Well, I don't have anything here marked parallel. The other one that talks about opposite sides are this number 2. It says both pairs of opposite sides are congruent. So let's look at both pairs of opposite sides. I've got my top and my bottom that have a single tick mark on them. So my top and bottom, that opposite pair is congruent. And then my left side and my right side, those opposite sides are parallel and congruent. Okay, so I can tell that opposite sides, or sorry, not parallel, are congruent. My top and my bottom are congruent. My left and my right are congruent. So both pairs of opposite sides are congruent. I'm going to say yes, and that was number 2. Both pairs of opposite sides are congruent. Even though it's the same tick mark all the way around, that's okay. By my theorem number 2. Okay? All right, so that was my bell. I'm going to do 2 more real quick, and then I'm going to need to head out to class. Number 3, I can see I have a pair of opposite sides that are parallel, here and here, and I have a pair of opposite sides that are congruent. The only one that talks about both parallel and congruent is number 5, but it needs to be one pair. I've got the top and bottom parallel. I've got the left and the right congruent. So this is not going to work. I'm going to have to say no on this one. And remember when we talked about counter examples? Even though I can tell this doesn't look like what I'm about to draw, I can draw something where the top and the bottom are parallel and the left and the right are congruent, but it's definitely not a parallelogram. If I draw a trapezoid, which again we're going to talk about a little bit more later this week, that has congruent sides, my top and my bottom can be parallel, because they have to be if it's a trapezoid, but my 2 sides are not parallel. So this is a no. Even though it looks like a parallelogram, we have to say no. Okay? All right, number 4, it tells me the distance from A to C is 25. So from A to C, that's this diagonal right here, is 25. So it tells me that whole diagonal. It doesn't tell me what's going on with that diagonal, just how long it is. And then my diagonal from B to D is also 25. So I have congruent diagonals. Okay? When I look at my information about diagonals, the only one that talks about diagonals is going to be number 4. And it says diagonals bisect each other. So the diagonals are cutting each other in half. This one just tells me how long they are. It's not telling me that these are cut in half. So this one is also going to be a no. Okay? In the next video, we're going to pick up with number 5, and we're going to decide our 5, 6, and 7, can we prove that they are parallelograms? If you'd like, pause the video or stop it here and try to guess on 5, 6, and 7, or not guess, but use your theorems to determine whether or not they are, and you can check your answers in the next video. All right, thank you so much for watching.